Hello, everyone. In this session of Tea Time, we're going through some cool Linux commands and Slurm jobs to submit jobs in. You can submit one job as our Python, MATLAB, or any file or function that you have, or you can schedule your jobs. And the benefit of this is that it can submit large files with heavy codes. So first of all, we need to have some Linux commands. Sudo command as superdo user commands, apt-get, ls, du, copies, removes, and move commands, which I will explain shortly. So because in HPC we don't have sudo permissions, I would like to do the sudo commands in my local computer, which I will do sudo. Then you can do apt-get as to install, for example, any software or any package that you want, X2Go client or anything that you want. You can install with that. You can do update, sudo apt-get update, or sudo apt-get upgrade. The difference between apt-get update and upgrade is that update goes to your lists and updates the packages that are there in your list file. Upgrade will upgrade all the versions of your packages that are installed. It will find from all over your computer. You can do sudo apt-get auto remove to remove the files which are as dependencies as the files as the packages that were installed but is no longer used. So it will take care of those. You can use sudo apt-get auto clean, which cleans the .deb files, .debm. Yes. Yes. Looks better. And yeah. I don't think so. No, it doesn't. Zoom in. A little bit more zoom in. Yes. Is it better? So sudo apt-get auto clean cleans up your files, mainly the .deb files that it will clean up a lot of spaces and will give you a lot of space to use, and for the functions that you don't have it. So knowing that, I would like to go to HPC environment, which it was explained in previous sessions. Let me see if I can enlarge this. Will work here. Yes. Bigger. Okay. So I can have here a lot of commands. I'm starting with the basic one, which is the ls. I want to know the list of the files that I have, what I have as a list of the files, and what I can reach to. And ls has different options that you can. Any command in Linux has different options. You can always do help for that function, and you can get for all the commands that is needed for that. But this time I want to go. So if I do ls, it will give me the list of the files. If I do ls-l, it will give me the list of the file with the information of the permissions, the file, the subdirectories inside, the owner, or and the group that I'm using in, the size, the date and time of the last update, and the name of the files. So we can do different things with the ls again. So if I do ls-lh, I want to have these numbers readable, human readable. I do ls-lh. It gives me in kilobytes, megabytes, and stuff, so I can read them. If I do ls-lht, it will give me sorted the files and the directories and subdirectories sorted based on the last update that I did. If I do lstr, which we usually do because the list of the files usually is like doesn't fit into a window. So in the last row, you can see the latest modifications that you had, so you can keep the track of that. You can sort it by capital S, which will sort it based on the size of the files that you have. So it will be helpful for you. Sometimes there are different users in a directory. So like in a group, you're working and you're writing files. In a group, mainly it happens in HPC when you submit a job. It goes to a temporary directory, so you need to manage that area as well. Sometimes you write a lot of files, you need to delete them or something like that. So for that, you need to grep the user that you use it, like AXK846. This is my user. You do. So it gives me just a list of the files, and with the user, which is AXK846. And you can, sometimes you have a lot of files. You want to list the files that are CSV files or any file, or RTF or any file. You put star and say ls-l star.csv, which give me the list of the file which are just CSV files. So knowing that, another useful command is the disk usage. So if I do du, it will give me disk usage, which will give me all the subdirectories disk usage. Again, this is not very human. Like, what is going on here? So it searches for any the size of any of the subdirectories and gives me that. So if I do disk usage and then do again etch, it will give me those files in human readable format. I can do sh, which will give me just one value as one summary, because it will take time. I think I'll need to cancel it, but s will give me a summary of whatever I have. I can do disk usage and put the layer of how much in depth I want to know the disk usage. For example, if I wanted to put the 2, then it will give me the disk usage of just 2 layers, like 2 subdirectories that I have, and then I can have more information. Again, I'm making it human readable, so it gives me the information of subdirectories in that manner. So if I can do hs, it will sort it for me. So now I have everything sorted. It gives me the summary for that. I guess it's hs. Yeah. If I do hs, I think it gives me the summary. I need to check. Okay. Yeah. So for that, I need to do sort and hr. This will sort me. So if I do, again, I'm doing it again, as sort -h, sort in human readable way, and r means that reverse. So I can have the reverse format, the largest at the top and the shortest at the bottom. So if I do just edge, it will give me the last ones as the largest files that I have. So knowing these, I'm going to have okay. So knowing these commands, let's go through making some jobs to submit for a Slurm job and see how it works. So I'm making a directory of Slurm t-type, and I'm going through that Slurm t-type. Now it's empty. We can have a lot of commands here. I guess you're familiar with copy, move, rename, and stuff. So meanwhile, if we need them, I will explain. But let's make some R functions and the equivalent the Slurm jobs for that. So for that, I do Vim command for like this is whatever you like. You can make a function, you can make a text function or something like that. But I'm making a test.r function, which my test.r function can be, for example, print probe. And because I want to work with my R function to show that how the Slurm jobs work, I need to make like a hold in my job or function. I use sys.sleep. I can pass the argument anything I want, like 100 seconds. Let's see, 100 seconds. That sleeps like for 100 seconds. I can make a data frame. I can make a data frame. I can assign data frame at arg1 equal to 1. I can assign data frame at arg2 equals to 2. I can make the data frame as a and I can write the data frame as file equals to testdf.csv file in my in the directory that I'm using the file. So this is the file that the R simple function that I'm having. So if I test again, I have print hello world system.sleep 100 seconds, a df a data frame with the arguments of 1 and 2, and I want to write that CSV. Okay, so let's go through how we can submit this as a Slurm job. So we have a template, like an Case Western Reserve has made it a very perfect template of how to submit a Slurm job. But for that purpose, first I would like to go line by line and let's write it ourselves, and then after that we can use that template. For that, first of all, I need to be on a compute node. For being in a compute node, I should do srun and --x11 --pty and bin bash. This gives me a compute node. You can see that here I have compute node of 240 come to 148T. Oh, sorry, I forgot something. So with doing exit, you get out of that. So first of all, I need to do module load stdenv standard environment, which loads which has the standard environment modules in this. First, I use this, and then I do srun --x11 pty and bin bash. This srun can be modified. You can have whatever nodes you want with the combination of the cores, the memory that you want, the time of the process that you want. So you can, let me see how it works. So you can say \x11 number of nodes, I would say 1. Number of cores, I would say 2, and the time can be 2 hours, and the memory can be, for example, 8 GB, and then in bash. I'm not running this, but if you do this, you will get this much allocation. Be really careful how much you want to use, because you might want to get fancy, like very large amount of memory, a lot of cores, a lot of nodes and stuff. But then the drawback is that you need to wait for those resources to be allocated to you. So with simple srun command, I can submit my job. So I'm okay with this, and I'm going to submit my job. So the other point is that you can get for this. I don't need it, but you can get both CPU and GPU nodes in your jobs if you need GPU for that. So I'm going through making a test Slurm file. So the Slurm jobs that you want to submit, the file extension is .slurm. So you make a test. I name it test Slurm as a test_slurm job. So I'm going inside it and see what I need to do. So what I will do is that I will do bin bash. It means that the Slurm it should run the bash script. The job should use a bash script to use not any other shell, but bash it should use. Then I start assigning my nodes and cores. So I do sbatch and the number of nodes, which is 1. I do sbatch number of cores, which I'm making it very minimalistic. I do sbatch and then the memory per CPU. CPU equals to 1 GB, and then dispatch time is, you can assign time, I guess 10 days, I think, but you can have days of operation in this Slurm jobs. But for us, we can go through 30 minutes as a time. So if your job cannot be done in 30 minutes, it will fail. It will stage you out. So be very careful on the job that you're submitting. You can do dispatch output, which is very important to know the status of your Slurm job. So there might be different errors in your functions. One is the output of the Slurm job. The other is the output of your functions. You need to be aware of both problems that happen. This will give me the sbatch output, will give me the output situations of my Slurm job. I name it my.stdout, and it will give me the information. So if your Slurm job is successful, it will be blank. Nothing will be reported. But if you have problems, it will report that. You can mail the user the like the status of your Slurm job. You can say, I want to have which type of status I want to be reported or emailed to me, all or fail. You can have different options. For this, I'm doing all. So anything, the job has been started, the job has been failed, the job has been a stage job, or you have an error in the job, it will be reported to you. And you can do dispatch the job name, which you like. Okay. So knowing that, now we have made our dispatch requirements of the allocations that we need. Second step is to call the modules that we need. So it's module load. For this, it's an R function. So I do modulo HPC ODS R slash 0 EL. So it's it loads this module, which is to be able to run the R function that I have, and then I do R CMD and batch, and the function name. I need to have this exactly the name of the function, the file name of the function that I generated. So I'm going to check it. So it was test.r, so it was correct for me. So it's rcmd batch and test.r. So let's see if it is successful and it works. So I have nothing in here. So for the running of the Slurm function, I can simply do sbatch test slurm.slurm. The job with this job ID has been submitted. Now you can see that I have test.r out. I have my.std out. Let's see what is the my.std out. I can do cat, which concatenates it, and due to module path changes, the following have been reloaded. Open MPI, so it did a kind of change on that. And then I can concatenate the test R out. Okay. Let's do rem test.r out. So this is the the output of your R out function. Let's see what was in test.r. So if I do SQE U and my username, I can see the jobs that are being submitted, and you can see a batch of a test is being submitted in this compute node that we have with this job ID that we have here. So SQ will give you information on your job's status. Very important to know. And With this SQ, you can do different things. Which okay. You can go to user. You can check the group that you're using the SQ, like in RxF131, which is Professor Roger French's lab. We can know that they're using, for example, and they have allocations on their jobs, and we can do we can do like SQ. If you do a simple SQ, it will give you everything, all the users that are using in the SQE, and many other things. So my job is done. And if I go to wim-test.r out, I can now see that, okay, I had an error in cat, in a problem in this area. I can know that my code was not correct. I need to go fix this error. So you can have access to all the processing time, the errors, any warning messages, and each step of your function, just like you're doing in your R console for your command. But it was for the writing of the test.tf, it was successful. So it it didn't write anything. So I have a test.r here that it had an error, and I might need to check this the error in the function, but my Slurm job did work, but my R function had errors, so I need to fix that error and resubmit the job. So I can do the resubmit the job. I'm submitting the job again to show that if you have the problem in your job, and if you wanna do resubmit it or something like that, you can do sbatch again, test R. Oh, sorry. Sbatch test slurm, which submits the job for you. And now you have in your SQE, you have this job that is started to running as a test file. So if I figure out that in the middle of the function, oh, I did a mistake on this, I do scancel, and I can't pass the job ID to this. And it will cancel the job that I had. Simply it can't cancel and stage job with the job ID. But you can do scancel with the user, but be aware that it will cancel your jobs or whatever you have as S run. It probably will cancel them. If you have RStudio running, it will cancel and it will be gone. So be aware that whenever you are doing scancel -u as when you want to do that. So I would so for the slurm command, the slurm command that I have, I need to do some more modifications to make it work better. So if I do vim as slurm, test slurm. So I had this, but I need, if you have very large files, you can't do it on HPC reliably. You need to copy the files to a temporary directory that has enough allocations, and after a while it will be gone, or you'll go delete them or something like that. For that, I need to assign or I need to copy everything that I have to a temporary directory recursively. Copy everything recursively to a temporary directory as pfs dir. So pfs dir is a temporary directory that copies everything over there and run, and then you need to go there and navigate there. So I do cd pfs dir, and then you will go there and you will the jobs will be submitted from that area. But be aware that if you're working in a directory that has a lot of directories which are large, it will copy them as well. So you'll see that it's taking much more than usual. So that is because you're moving everything with this command, moving everything from your local to pfs dir, which makes a chaos. If you have 100 jobs, it will copy everything 100 times, and it will be a mess over there. So all the time I recommend to submit the jobs in this very most subdirectories that you have, that you know that there is no large unnecessary and not required files in that. And then with that, you might want to then copy them back to a directory that you might need to know there. Like then again, I copy it to home xk846, and it was check. I'm making another directory of tester, slurm t time, and then tester. T time and tester. And okay, now if I submit the job dispatch, it will submit the job here. It will go to my pfs dir if I do pfs dir. Okay. Copy. Okay, you can see this is a pfs dir, like my temporary directory. It copied everything to the temporary directory. Now it works from this area, this directory, which is good because it's temporary. You can delete them or remove them, but you need to have a grep and then the user, and then you can delete them based on what you have the permission to delete. And then after a while, it's a temporary directory that will be gone. So with this, you can submit very, very large files. So I guess I had some more stuff about controlling of the Slurm job with scontrol, but I would like to give you the references that are generated for that, the reference for the CPU management on user and administrator guide, and SQ commands. So with the SQ, you can do a whole lot of things with each command, SQ, scans, scontrol. and a lot more. You can control everything in your Slurm jobs. You can cancel in any time you want. You can even hold it, or you can put the dependencies. So I need this job to be done after a dependency of the codes that is done. You can have those. So I highly recommend, if you're interested, go through these links. Also, Case Western has provided very, very, very good and informative documents about how to submit the jobs and running jobs, and what are the optimal job submission, and how to do that for our jobs for Python and for different jobs that you have. And then you can have information on the S batches, and you can even find the templates from these, how to manage these. So that was all from me. Any questions about the Slurm jobs and HPC? I would be interested in. Yes.
So do you know for our HPC what is the maximum configuration that we can use?
I think for groups, it depends on the groups that you're using. For us, we are using Professor Roger French allocations. So I think for the compute nodes, we cannot use all the nodes at the same time, and if we don't allocate the right resources, you'll wait. For sure, you'll wait. If you go fancy in the allocations, you might not be that much efficient. So per student, I don't know. I think maybe 30 nodes. I'm not sure for that. I need you can submit 30 jobs at the same time for a student. I guess. I think I need to check for those. Yes.
I could comment on that.
Yes.
So the group has the capacity to use 256 CPUs at a time.
Yeah.
So if you have rules within a group, and to restrict that on a per user basis, I'm not sure. But that's the total that you can use at a given time for the requirements of the group.
Yeah, 256 cores or nodes? Cores, yeah. Any other question? I guess we're 5 minutes earlier. Thank you very much for your attendance. Appreciate it. Thank you. I'll stop it.